Hello everyone, it's me again with some new math topic. Not for you, but probably with some new formulas and some new explanations. Now I know everybody knows trigonometry. Everybody who especially comes to engineering has seen trigs somewhere, but my experience says that in most of the high schools, the amount of training on trigs is so basic. And also, when you come to higher education, bachelor's, master's, PhD, the need for trigs is not that simple. So here, I'm going to show you a little bit more than what you probably have seen. I know everybody knows sine squared plus cosine squared is 1, or tangent is sine over cosine. Okay, so these are not the simple things I want to talk about. Some of them, again, you might have seen, like, for example, when you combine two angles, add them or subtract them, I assume you have seen that what is, for example, sine of A plus or minus B, correct? If you haven't, check it right now, but most of you have probably seen it, so I'm gonna put them down there for you. So this is going to be sine of A times cosine of B plus and minus basically cosine of A times sine of B. So you probably have seen that one plus the cosine version, correct? Like, what's the cosine of A plus minus B? So this is going to be cosine of A times cosine of B, and then pay attention to this part, minus plus sine A times sine B. What does it mean? It means if it's a plus, that is going to be a minus. If it's a minus, it is going to be a plus. Okay, so we know that. Now, one of the things I saw most of my students did not know was the tangent. What's the tangent of A plus minus B? And you have to divide these two terms together and then divide the numerator and denominator in it by cosine A, cosine B. If you do that, you'll see you end up with tangent of A plus and minus tangent of B divided by 1 and again it is minus plus tangent of A times tangent of B. So again, plus means plus in the numerator but negative in the denominator. Negative means negative in numerator but plus in the denominator. So these three are some of the important stuff that you can find all of those equations, like what is sine of x plus pi over 2, what is cosine of x minus pi, and so on. You can find them all through these three important equations. Okay, so I'm not going to go through those because you know them. And many other entities also come from here. Like, for example, if you make a and b to be equal, then you can find sine of 2a, cosine of 2a, and tangent of 2a, which are important. So these are the sine, cosine of twice angle. So sine of 2a is equal to 2 sine a cosine a. Then cosine of 2a is going to be cosine squared of a minus sine squared of a. You can also write it as, if you replace sine squared with 1 minus cosine squared, you will also replace, you can rewrite it as 2 cosine squared of a minus 1, or 1 minus 2 sine squared of a. You can also write it that way, and of course tangent of 2a, if you do it, you are going to get 2 tangent of a minus over 1 minus tangent squared of a. Okay, so these double angles are very useful, and also you can find through them the half angle, right? Because if you replace a with a over 2, then from here, setting this equal to that, again, if you replace a with a over 2, this is going to be cosine a, that is going to be cosine squared of a over 2. And from there, you can find what? So from these two, if you replace a with a over 2, you can see that you will get cosine of a, and you can take this negative to the other side, plus 1 is equal to 2 cosine squared of half angle, right? And from here you can find cosine of half angle. And then if you set these two equal, so you say this one equals this one, and then bring them down. So from these two, again, if you replace a with a over 2, and this time take this cosine to the right side and the 2 sine to the left side, you will get 2 sine squared of a over 2 is going to be 1 minus cosine of a. Therefore, you can find what? Sine of half angle. Okay, so these two equations are important for sine and cosine of half angle. Okay, so here, these are the equations that matter. This two, I call them set 3. These guys, I can call them set 2. The most important one is, of course, what? This set number 1. So sets 1, 2, and 3. These are some important things. Now let's raise the bar a little bit and make it more complicated for you. So one of the things is if I give you an equation that involves sine and cosine at the same time and you have to solve it, okay, for the angle that arises in many engineering applications, specifically when you do the 4-bar linkage, for example, right? If I give you 4-bar linkage, so let me show you what I mean. Let me show you by example. So here you have a 4-bar linkage, something like this. Draw straight lines as much as possible. So here you have this mechanism, and here we assume that these two pins at A and B are at the same level, and this is a pin at C and this is a pin at D, and I call this length A1, A2, A3, and the distance between A to B, I call it A4. And then the angles with respect to the positive x-axis, if you want to call them, I call this angle theta 1, and then I call this angle basically theta 2, and then I can call this angle from here theta 3. And then if I want to, I can use these angles, right, and find what I need to find, or if I want, I can measure every angle with respect to the negative side to avoid a bunch of conversions. So if I want, for example, I can call this angle, let's say theta 3, make life easier. I can make this angle theta 2, and I can make this angle theta 1. This will basically makes my life a little bit probably easier when you come to derivations. So here you can set your coordinate anywhere that you want your origin. Let's say I put it here right at pin A, and so this is my x-axis, this is my y-axis, and here if I give you angle theta 1, can you give me angles theta 2 and 3? Because this is a mechanism with 1 degree of freedom. So once you know one of the angles, you should find the two other angles, right? So if I give you theta 1, the question is, what is theta 2? What is theta 3? Okay, so let's look at the nature of this problem here. So first, I look at the x values. So if I start from here, this x component is a3 cosine of theta 3, and then plus a2 cosine theta 2, right? Then minus a1 cosine theta 1 is equal to a4. Or I can say a1 cosine theta 1 plus a4 equals a2 cosine theta 2 plus a3 cosine theta 3, right? Some of the x's are the same. So here, let me write it, a4 plus a1 cosine theta 1, which is a known number, is equal to a2 cosine theta 2 plus a3 cosine theta 3, correct? And assume that the length of the members are all given. So I know a1, a2, a3, and a4. So that's equality of the x's in the loop. Now for y's, you go up as much as a3 sine theta 3, and then go further up as much as a2 sine theta 2. That should be equal to a1 sine theta 1 because this member is horizontal. So you can say a1 sine theta 1 is also equal to a2 sine theta 2 plus a3 sine theta 3. Well, clearly here I'm looking into two equations and two unknowns. They are algebraic, but the thing is these are nonlinear in terms of theta 2 and theta 3. I'm not directly looking for thetas. The terms that are involved are their sine and cosine, and these types of equations, we call them in the literature, we call them let me use all simple letters, no cursive, transcendental equations. Okay, so these types of equations involving exponentials, harmonics, and so on that are not polynomial type, we call them transcendental equations. And solving transcendentals analytically, not numerically, as I told you with Newton-Raphson or others, it's not as trivial. So how do I handle this problem? So this is what I do. If I call this equation 1 and I call this equation 2, now I want to solve from 1 and 2 what? For 2 and 3, correct? So what I do, first I try to use the important thing that sine squared plus cosine squared equals what? Equals 1. So what I do, I square equation 1, I square equation 2, and add them together, see what they give me. On this left side, I will get a 4 squared plus 2a1 a4 cosine squared of theta 1, or cosine of theta 1, sorry, not cosine squared, plus a 1 squared cosine squared, and then plus a 1 squared sine squared, right? This guy is equal to, and in the bottom I have basically a 2 squared cosine squared plus a 3 squared cosine squared for theta 3 plus 2a3 cosine theta 2 theta 3, and then similar terms for sines, which is going to be like a 2 sine squared plus a3 sine squared plus 2a2 a3, the product of the sines. Okay, so now it looks like a big mess. But the thing is, all of this left-hand side is known value because you know theta 1 and theta 4, correct? And if you want, you can even add these two together, and this is simply a1 squared. So now, what I would do to get a little better with my notations, I would call this whole thing, I give it some name. For example, I can call it parameter A, which is completely you can calculate it when theta 1 is given. Now, what can you do to the bottom side to make life a little bit nicer? So you would combine this a squared here and this a squared here to make it simply what? a2 squared. And then you factor out here the a3 squared term here and here. And these guys will give you a3 squared. And then you want to see if you can also combine these a2, a3 terms. If you do that, you will get a2, a3 times 2 times what? Cosine theta 2, cosine theta 3, and then minus sine 2 sine theta 2 plus sine theta 2 sine theta 3. Okay, so now, does this look any familiar to any of the things we learned in the past? Yes. If you come here and look, it is very similar to a cosine term, except this is the plus, so I have to have minus. So it looks like it's cosine of A minus B. In this case, it is what? It is cosine of, let's say, theta 2 minus 3 or theta 3 minus, well, it is 2 minus 3. Yes. I'll do 3 minus 2 is going to be the same because cosine is an even function. So negating the input argument is not going to change anything. So now if you look, A is equal to a2 squared plus a3 squared plus 2a2 a3 cosine of what? The subtraction. And well, that's not bad because from here, if you take a2 and a3 to the other side, divide by 2a2 a3, that gives you cosine of the subtraction of the two. Okay. Now, it does not give you both angles, right? It just gives you the difference between theta 2 and theta 3, right? So, is there any way now to... so, if I write it, let me write it down for you. So, the result is going to be a minus a2 squared minus a3 squared is equal to 2a2 a3 cosine of the subtraction. And if you want, I can put a here for you. A was a 1 squared plus a 4 squared, and then plus 2a1 a4 cosine of theta 1, correct? If I'm not mistaken. Right. And again, now this whole thing is a constant. If you want, I can call this one A or this one B. It doesn't matter. Or when I divide it by 2a2 a3, I can call it what? B. So if you want, I can now divide both sides by 2a2 a3 and get rid of this term. And now this guy here, I can call it whatever you want. Does not matter. So I can call this whole given number B. So now the cosine of theta 2 minus 3 is a constant, so I can take cosine inverse from both sides and find the difference between the two angles. But I also need another equation that can help me find what? Another relation between them, and then combine the two to find theta 2 and theta 3. So how can I find it from here? So you see how trigonometry is important, right? So far all I did was to use this identity of sine squared plus cosine squared equal 1. I haven't done anything else, but now is the time to do a little bit more advanced. So now let's here take our cosine from both sides, and from here you clearly can see that I can say theta 2 now minus theta 3 is cosine inverse of b, which is a number, correct? And from here I can replace theta 2 as a function of theta 3. So I can say theta 2 is now theta 3 plus cosine inverse, and if you don't mind, I would like to replace also this with c, because I don't want to keep writing cosine inverse. So I write it as c, and now I call this equation number 3. So here theta 2 is given as a function of theta 3. So I'm going to replace it in one of those previous equations, 1 or 2. I can only replace it in one of them. I cannot replace in both and say, yeah, I have now 3 equations. No, you have 2 equations because equation 3 came from 1 and 2 is not independent from them. So let's say I would replace it in 3. So what I will do, I put 3 into 2. That will give me what? A1 sine theta 1 is equal to what? A2 sine of what? Theta 3 plus c plus a 3 times sine theta 3. Correct? And now here I use the expansion of sine of a plus b, which I had all the way up here. So if I do that, then this term here is going to be what? Sine of theta 3 cosine of c plus cosine of theta 3 sine of c. And remember, sine c and cosine c are single numbers, as well as this a1. So whatever here I underline for you is a known number. And now if I factor out the sine theta between this first term and the last term, then I will get something like this. That sine of theta 3 times what? Times a3 plus cosine of c plus cosine of theta 3 times sine of c. This is equal to another constant here. If you don't mind, I would call this d, because it's a given number, equals d. So now, if you look, my equation is now simplified to this. And now I can call these constants e and f, because again, they're constants. So now my equation is like this: e times sine theta 3 plus f times cosine theta 3 equals d. Now I have one equation, one unknown, with given numbers e, d, and f. So what we do here, we try to use some trigs, and we try to use the half angle. What do we use exactly? So if we go back to the half angle here, you see that sine half angle or sine squared half angle is basically 1 minus cosine A, and 1 plus cosine A is 2 times cosine squared of half angle. So basically I can say that, let me do it on a separate page, that 2 sine squared of half angle divided by 2 cosine squared half angle which is of course equal to tangent squared of half angle. This is equal to, if I replace from those equations, this is going to be 1 minus cosine of A, and this is going to be 1 plus cosine of A. Okay, therefore, if I want to replace cosine of A based on tangent half angle, so what I need is to cross multiply and then take cosine A all to the one side. So if I do that, I will get basically cosine of A times this one goes and then multiplied by tangent squared, added to the tangent squared. Okay. And then here I have a 1 on this side, then I have a tangent squared which goes to the other side. And from here I can replace cosine A wherever I want based on the tangent of half angle. Okay, so that's one of the important trig equations that I will use for solving that equation. Okay, and I will call this equation number 4. The other one is, from here you can also find sine of A based on tangent of half angle, right? We know sine squared of A is 1 minus cosine squared of A. And if I replace cosine from the top equation, so basically this guy, Control C, and then come down here, Control V. So I need to raise this guy to the power 2 and subtract. And if I do that, in the denominator, I will get this term, whole thing squared. And now this term, this same term, have to be subtracted from that 1 minus. Squared. Correct? Taking common denominator. And now when you expand this, this is going to be 1 plus tangent to the 4th. This is also going to be 1 plus tangent to the 4th. They would cancel out. Here you're going to get 2 tangent squared minus 2 tangent squared. So it is going to be 4 tangent squared of A over 2. So if you simplify this whole thing, that's the result. And now if you take a square root, this 4, this tangent square, and this power 2 would be eliminated. And from here, sine of A will be 2 tangent of A over 2 divided by 1 plus tangent squared of A over 2. And this is the next thing I will use in that equation. I call it 5. So you see, in 4 and 5, I can replace sine and cosine of any angle based on tangent of half angle. This 4 and 5 use a lot in equations that are transcendental. So now here I say this is what? This is tangent of theta 3 over 2 divided by 1 plus tangent squared. And this guy is 1 minus tangent squared over 1 plus tangent squared. Right? And now if I multiply them by EF, take a common denominator and use D and rearrange everything. So I would rearrange, multiply both sides by 1 plus tangent squared, rearrange everything, I will get an equation like this. The tangent squared of theta 3 over 2 times, so it is going to be a negative D term, And here we have negative f plus tangent of theta 3 over 2 times. Now here I will have an e term, and the constant will be negative d and f, like that. And now guess what? This is a quadratic equation based on this tangent of theta 3 over 2. So if I call this theta tangent of theta 3 over 2 x, this guy is x squared. And now clearly you see it's a quadratic equation. So now I can say that this tangent of theta 3 over 2, I can find it based on quadratic solution. So what I can do is multiply both sides by a negative to make these two guys positive. This guy is going to be negative. This guy is going to be d minus f. So it's negative b, which is e, plus and minus b squared, which is e squared, minus 4 times d plus f times d minus f. 4ac, and then divided by 2a. And clearly this here you can simplify a little bit further. So it is going to be e plus minus square root of e squared minus 4 times this is going to be d squared, and then minus f squared times negative 4, so it is going to be plus 4f squared divided by 2 times d plus f. There we go. Right? So now that number, whatever it is going to be what? Tangent of theta 3 over 2. And if I call this whole thing, whatever you want to call it, m, then clearly theta 3, the solution, is going to be 2 times tangent inverse of m. Now, finally, I got my theta 3. And if I call this guy 6 and plug 6 back all the way into 3, correct? So from 6 into 3, you'll find that your theta 2, it is going to be c plus that solution. C plus theta 3. Right? And you can call this 7. So now I have what? Both angles calculated, 2 and 3, excuse me, based on m, and m is based on numbers EDF, and EDF are, as you can see, based on what? Based on constants, correct? So E is a number based on C, and F is based on C, where C is constant of B. B is defined based on the angle, and D also is defined as A1 sine theta 1. So if you go back, you can of course rearrange it back all in terms of theta 1 and A1, A2, A3, A4. These are going to be quite chunky big equations, but you see everything is analytical. So now for any theta 1, you can find theta 2 and 3 what? Analytically, thanks to these very important trig equalities or identities. Okay, so here I showed you how to solve a transcendental equation with one example in engineering, and here are some other important tricks. Now there is one other way that you can attack this problem here, this guy, this one. This equation, there is another way to attack it, and that is using this identity that says if you have a sine of theta plus b times cosine of the same angle theta, you can write this as square root of a squared plus b squared sine of theta plus tangent inverse of a over b. Okay, so it's a number, this is a number. So this way you can write this whole thing as sine of one angle. And now if this guy is equal to d or whatever it is, then you divide both sides by this number, take a sine inverse, and then subtract this guy from both sides. That will also give you theta. So that's another way, using this important identity, that you can attack that problem. Could be even easier. Okay, so I assume that I have shown you this. Now I want to show you a couple of other important tricks. These are involving inverse functions, and then hopefully you know a little bit enough to proceed with solving math problems in higher education. So you all know that if I give you sine of sine inverse of x, you know the solution is going to be x, of course under specific ranges for x and specific conditions, and sine inverse of sine, you can also call it what? X. Now what if I ask you what is cosine of sine inverse of x? And you'll see this guy a lot again. I'll show you an example in a second, but how do I solve this? Or harder than that, I can say what is tangent inverse? Tangent of sine inverse, or something like that. When you combine a trigonometry and another inverse that are not the same, how can you find the result? So the way to go about it is, if you call this whole thing I, then this is cosine of I. You can say cosine of I is what? Plus minus square root 1 minus sine squared of I, correct? Cosine of I, sine of I. Now what is sine of I? Sine of I is clearly what? Sine of, let's replace for I, sine inverse. So it's what? It's x. So this guy here is simply what? X squared. So the result is going to be plus minus square root 1 minus x squared. Okay? By a simple change of variable, you can easily do that. Now you might say, where would you use this? Well, one of the places you use it is in drag equations for a projectile. So if you have a projectile up in the air moving in this direction, so this is v, and this angle is theta, you know that the drag force is acting opposite to the direction of the velocity, and if I use traditional x and y, right, and let's say I also have mg, here I'm neglecting lift, just drag and mg. So if I want to write the equation, sum of the forces in the, let's say, any of them, doesn't matter, in the x equation, it is going to be, since this angle is also theta, is going to be negative fd times what? Cosine of theta, right? Now what is theta itself? As you know, theta is tangent inverse of vy over vx, correct? It gives you the angle of the velocity, or if you want to write it in terms of x dot and y dot, you can say y dot divided by x dot. So now if I plug this down here, I will have cosine of tangent inverse of something. Is there any way to simplify it? Yes. So the question here is, what is cosine of tangent inverse of u? Right, where u here is y dot over x dot. Can I solve for this? Yes. So what I will do is this. Again, I will call this guy I, and I say cosine squared of what? I can be written as what? 1 over 1 plus tangent squared of y, correct? You know this equality, correct? There are two important equalities, and other ones, where 1 over sine squared of any angle and 1 over cosine squared of any angle. So this is going to be 1 plus tangent squared. This is going to be 1 plus cotangent squared. Okay, so here I'm using the bottom one, of course the reciprocal of the bottom one. but that's what you see here. And what is tangent here of I? This guy. It is tangent of tangent inverse of u, which is going to be u. Okay, so this guy is u squared. And 1 over 1 plus u squared is cosine squared of what I'm looking for. So the cosine itself is going to be what? If I'm asking for the cosine itself, then this cosine itself is going to be square root of that. And the square root here is going to be plus minus 1 divided by square root 1 plus u squared. Correct? So if I replace this u squared for myself with y dot squared over x dot squared, and this x dot can come out, you will get plus minus x dot divided by square root of x dot squared plus y dot squared. Which, by the way, this is magnitude of what? This is magnitude v, and then of course x dot over v is cosine of theta. Okay, so you see, these are the cases where these combination of trigonometric and inverse trigonometric functions appear in engineering. So hopefully I could have given you a bunch of useful methods and identities that you need in trigs. And watch the previous video I made on the laws of cosines and sines and a bunch of other important equalities. There are a couple of more. Let me write them before I end up this lecture, and that is converting your summations into products and converting products into summations. These are also important, so you might have seen them, and I assume you did, but sine of A times sine of B can be written as 1/2 times cosine of A, basically minus B, and then minus cosine of A plus B. Similarly, cosine A cosine B is also 1/2 times cosine A minus B plus cosine A plus B. And finally, sine A cosine B is 1/2, and then you need the sine terms this time. So it is going to be sine of course, A plus B, and then plus sine of A minus B. And if you want, you can go with sine B cosine A, but it's just changing these arguments. So I'm not going to write it because that's the same as this one, just changing the arguments. And of course, going back to writing summations as the product. So if I want like sine of x plus or minus sine of y, this is equal to basically 2 times sine of the average, and then times cosine of that. By the way, you know what? Let me use A and B instead of X and Y, because I did everything today based on A and B. So let me still use A and B. Okay, and then you have, so this is sine plus sine, then I can do cosine plus cosine, okay? So if I have cosine A plus minus cosine B, then this is going to be 2 times cosine of the average, or the A minus B divided by 2, times cosine of and then you have a minus b divided by 2, and by the way, this is only plus. If you want minus, that's based on the sine terms, not based on the cosine terms. So if you want cosine A minus cosine B, it is based on the sine terms. Okay, so you have to write it like this. Okay, so here in the top, I'm converting product into summation. In the bottom one, I'm converting summation into product. So hopefully I have given you enough of tricks so you can succeed solving different equations involving these functions in your higher education. Thank you.